Welcome to the Indium Corporation booth here at IPC APEX. I'm joined by Chris Nash, who's the product manager for solar materials. Nice to see you, Chris.
Thank you. Thank you for having me.
So, Indium for the last couple of years actually has been involved in a campaign on Avoid the Void. It's very much a big part of the marketing you've been doing essentially. But you're involved in the materials side of the business.
Correct.
So tell us a little bit about what some of the latest developments have been in that.
Sure. So we wanted to expand upon the Avoid the Void campaign because it's easy, or it's relatively easy to develop a solder paste specifically for lowering voiding. So we wanted to make sure that our materials had other characteristics that our customers were or felt important. So we wanted to make sure that it had excellent response to pause, ICT, head and pillow minimization, and a lot of other facets that people are interested in, and not just voiding. Sure, our products void lower than a lot of other products on the market, but they have to perform in other avenues as well.
Right, okay. And how have you managed to achieve that then?
Well, it's all in the flux technology. So it's proprietary information, but the formulation of the solder flux vehicles of the solder paste is really the important part.
Okay, so there's no actual change to the alloy, it's just the flux structure.
Correct. Now, other avenues like the high reliability alloys that we've developed, Indolite 276 for automotive applications, under hood applications, those are really the alloy developments that we're focusing on to do thermal cycling reliability from minus 40 to 125, minus 40 to 150, and also future proofing at minus 40 to 175.
Right, okay. Yeah, I mean, certainly the automotive industry has been trying to drive these testing cycles, beyond 150. So it's quite a challenge.
Absolutely, and I don't think it's just the automotive industry anymore. It's the LED industry. It's the industrial industry. They're looking for high reliability alloys that they can rely on for these high reliability applications.
So, coming up next year, basically the RoHS regulation for bismuth and stuff like that is going to be disappearing. Are you preparing any alloys along that front that's going to increase the bismuth component? Well,
we have a lot of the industry is talking. There's a big buzz in low temperature solder, so that's really where the bismuth comes in. We've been a part of low temp since our founding in 1934. Indium Corporation. Indium is another low temp offering. So Indolite number 1 was developed in 1934 as a low temperature alloy. So we're familiar with low temperature. Bismuth tin, silver are probably the more popular ones because of the cost effect. So we are working on higher reliability alloys in the bismuth tin and low temp solution realm.
Great. So coming back, just circling back onto the voiding, we talked a little bit off camera that certainly those flux chemistries are used to help reduce the voiding component, but there's also a need for mechanical as well if you're going to really get these voids down to a decent level. What's your view on that?
It's really important that not only the mechanical reliability, but also the thermal reliability of these large bottom termination components. That's becoming more and more important as thermal capacity goes up and the electrical voltage goes up as well, so it's creating more heat. So it's really important to have lower voiding to be able to supply high reliability products there.
Right. Exactly. And of course, a lot of this is coming from miniaturization as well. That's driving all these thermal excursions up.
Sure. Yeah. Just the stencil thicknesses are going down because of miniaturization. So that is actually going to increase voiding as well. If we've seen that an increased thickness in the stencil from say 4 mil to 5 mil will actually reduce your voiding as well. So there's other things that can be done other than the solder paste alone.
Fascinating. Well, Chris, it's always it's nice to catch up and see what's happening at Indium Corporation. Thank you for joining us today.
Thank you for having me.